Okay, one more, excuse me, one more last set of problems. We're looking at number 27. Find the slope of a ladder placed 4 feet from the wall and touching the wall at a height of 12 feet. Um, I, uh, I can see where you could get two different answers. As far as the grade's concerned, I put 10 points on the on your test score, so that'll some part of that'll make up for this question here, because I could see where you could get 3 or -3. But let's just see. We've got ladders. A ladder up on side up against a wall. It could be on the right side or on the left side. Okay, if it's on the left side, the slope is rise over run, change in y over the change in x. So I'm going up 12 and over 4 to go from one end of the ladder to the next. So my slope is 12 over 4, which would be 3. Notice this is a positive slope, rising rising up from left to right. And then if I were to look at the slope here for this one, I would go up 12 and 4 to the left to get back onto the line. So that would be a slope of -3. So we could have A or B in this case. So that's number 27. Rise over run. Remember, slope is how far up and over you're going from one point on the line to another point on the line. Okay, number 28. A quadrilateral has the given vertices. What do the slopes of the sides prove about the quadrilateral? Okay, you might want to look at this one again in your note-taking guide. Let's just label these points A, B, C, and D. Okay, if we were to graph them, it may not look like this, but I'm just going to put a figure here like I told you, just so you can tell what segments are opposite and what sides are consecutive or adjacent. So remember, when you're naming a polygon, you start at any vertex and then you just go clockwise or counterclockwise and name the points, name the vertices. Just don't zigzag. All right. So we see that we've got a segment AB, and then let's find its slope. Segment AB. So the slope is going to be, I'm going to do -1 -3 over 4 minus -2, and that is equal to -4 over 6, which is equal to -2 over 3. And then for BC, I'm going to do -4 minus -1 over -3. Make sure you subtract in the same order, so I've got -3 minus 4. Okay, so I have -4 minus -1 or +1, so that's going to be a -3. And -3 minus 4 is the same as a -7, so that's 3 over 7. So that's for segment BC. And then let's do segment CD. So for CD, I'm going to do 0 minus -4 over -4 minus -3. 0 minus -4 is 4. I got -4 plus 3, which is a -1. So I've got a -4 for the slope of CD. Okay, it doesn't look like we have any rectangles or squares here. Then finally we've got AD. So for AD, I'm going to do 0 minus 3. 0 minus 3 over -4 minus -2. And I have a -3 over -2. Okay, which is a +3/2. So when I compare my slopes, a quadrilateral has these given vertices. What do the slopes of the sides prove about the quadrilateral? We know with slopes that if the slopes are equal, then the lines or the segments are parallel. And if we know they're opposite reciprocals, or the product of -1, or if their product is -1, we know that the segments or lines are perpendicular. So when we compare the slopes, we don't have any that are equal. And notice here we've got a negative and a positive, and the reciprocal 2/3 is 3/2. So AB and AD are perpendicular. They form a right angle. So that would be answer choice what? Has no parallel sides and one right angle. So that would be answer choice B. Okay? Hope you found that helpful.